Okay, now we're going to look at the some of the advantages and disadvantages of concrete in construction of buildings. Concrete's most commonly we see concrete in being used for foundations, pouring the footers underground that provide the basis to be able to establish the masonry walls or the wood frame walls. Also, of course, for floor slabs, concrete is a very convenient method of providing a very flat floor surface over large areas. Driveways, sidewalks in our communities, almost exclusively made of concrete, simply because we can cover a very large area relatively economically as opposed to laying bricks or some other type of paving unit down. Precast concrete, on the other hand, is concrete that is formed and poured into forms in a precasting plant away from the job site. Precast concrete is starting to be really common in foundation walls, especially for residential structures. One of the advantages is they can have a very high degree of quality control, maintain control over the tolerances and the size and the dimensions of the concrete panels and units. And you can build an entire building using whole precast modular concrete units. And what they'll do is bring those big concrete panels, precast concrete panels, in on a flatbed truck, use a crane to lower them into place, and then simply bolt them together. They can assemble them in several ways. Here we see a precast concrete building. You see the buttresses or the fins on the outside of the building to add structural rigidity to the building. As opposed to precast concrete wall panels, we can have poured in place concrete, which is much more manpower intensive. We could see here that we have some wood forming being erected, and there has to be a wooden framework in place for us to pour the concrete into. And the concrete is just poured in like a mold. That's exactly what it is. It's a mold that's created on site. They will usually have some steel reinforcement already put in place inside that form, and then simply pour the concrete in and fill it up to the top. One of the downsides of this is that cast in place concrete has absolutely no strength until after it is placed and cured. And once it is cured, then of course the forming lumber can be taken away from the outside and leaving the poured concrete unit in place. Now, we have a type of construction referred to as curtain wall construction. What curtain wall basically amounts to is that the concrete that is used for the curtain wall construction really has no structural integrity to it. It is simply there to fill up the hole in the wall. What we'll see is a building that's built out of typically steel frame building, and then they will have concrete panels that are lifted into place in order to fill in the gaps in between the steel structural members, and sometimes to completely conceal the structural members inside the building. Concrete curtain walls have a certain number of difficulties with them. One of them is it's difficult to completely fill all of the cracks and the void spaces between the steel and the concrete. And this can, if it's not properly done, can allow for unwanted fire travel and fire spread under uncontrolled conditions. Now we'll look at some steel components and how they're used in construction. Again, steel is typically used for the structural framework of the building. It supports our floors, our walls, our roofs, and the exterior walls. And there's several ways that we can use structural steel in the building. One of the most common that we're familiar with is the beam and girder frame system. The connections are extremely important. At one time, steel frame buildings were riveted together. Found out over time that the rivets are not the strongest way to do things, and now things are pretty much either bolted or welded in place, or both. and they have to have a way to resist wind load and other lateral forces. Such as buildings built in California near the San Andreas Fault. They will have a certain amount of give built into the building in order to be able to withstand an earthquake. We have some classifications here. We have rigid, we have semi-rigid, and then we have simple. Steel trusses in the building can carry loads across greater spans than beams or dimensional wood members. Remember, we mentioned in the Type 3 construction with masonry, load-bearing walls, and wooden structural members, sometimes they will use steel structural members for the flooring because then they can span more than that 25 to 30 feet that we talked about with the wood flooring members. Some of these are the open web joists that we see here, or commonly referred to as bar joist, and also some joist girder techniques. Rigid frame buildings allow an increase in interior clear space. We don't have to have poles or posts inside our building. And they are fabricated by welding or bolting various pieces of steel components together. Crown and knees are designed as rigid joints with no rotation between members. There is absolutely no movement in a rigid frame building. Now we have steel arch or steel truss roof buildings. Again, where we have the need for a large unobstructed floor, such as say a hockey arena or a gymnasium, can sometimes be, they will use a steel arch type roof construction, and sometimes referred to as the trussed arch or just a truss. Steel suspension systems allow steel used in very slender forms. The problem with the steel suspension system is subject to buckling. When the suspension system is built, it's built under tight tolerances and controls, but if anything in the building were to shift or a load be placed in a place where it wasn't anticipated, it can cause structural integrity issues. One of the things that we will see will be a suspension roof system where we have the roof of a building is suspended from a framework outside of the structure. These are rather unique, but we are starting to see them more and more. Steel column. In order for a column to have structural integrity, the cross-section must be small compared to its length. There's a great possibility of a steel column buckling. Of course, the longer that a column is, the greater chance of buckling or bending or bowing in the middle. We can have steel columns that are relatively simple to some that are very complex in design, and the column is what holds the building up. It's the key to the structural integrity of the building. Now we're going to look at masonry construction. Masonry construction can be load-bearing or non-load-bearing walls, depending. And if you remember back when we discussed the Type 3 construction, we talked about the difference between how the brick veneer and the load-bearing brick wall appears. And the difference, of course, is having the soldier course of brick. Every 5 to 7 courses of brick will be in a different orientation, so it provides more rigidity, more integrity. Most of today's brick buildings truly are not brick buildings. They are wood frame buildings or steel frame buildings that have a brick veneer on the exterior. The thickness of masonry walls depends and varies on several factors. Remember, the masonry units are relatively heavy. So what we have are a masonry wall that's being constructed. Now the higher up we build with a masonry wall, the heavier the wall gets. So we need a wider base to the wall. And for practical purposes, a true masonry load-bearing wall construction building, the practical height that we can build is about 6 to 7 stories. And at that point, the thickness of the walls down at the base has to be about 6 or 7 feet deep in order to maintain the structural integrity and to be able to hold up the weight of all those masonry units. Here we have a diagram here of a reinforced brick wall where we have two Ys, or two courses of brick that are, I guess Ys would be the correct term, an inner and an outer Y of brick, and then we have steel reinforcing rods down the center of it, and then poured concrete in between the two to provide a great deal of rigidity. Whenever we have openings in a masonry wall, we can see here in the diagram on the left, we have several ways that we can do this for either doors or windows. We have to put either a cast concrete or a steel lintel across the top of that window or door, or we could build an arch out of brick and mortar, and you can see the bowed arch, bowed upwards, gives that arch a great amount of compressive strength, and it will not fail. Or we could corbel, or probably the weakest way that we could provide an opening in a door for a door or window, and it's not used very much today. On the right, we see our parapet wall, which is very common to see a concrete or a steel member casing over the top of the brick in order to keep water out. Interior structural framing, again, going back to looking at when we discussed the Type 3 construction, the wood framing members are socketed right into the masonry wall, and you can see that they have the fire cut here. The purpose of the fire cut was when they started building Type 3 buildings and had a fire in it, if one of these members burned out and now provided a lever, you have all kinds of unsupported weight now because the center of that beam or that joist got burned out. The weight of that member would then twist and turn and try to drop out of the brick wall, and it would work as a lever, and it would lift the bricks above it out of place and cause the masonry wall to become compromised. So what they did is they started fire cutting the end of that floor joist on an angle, as you see here in the diagram, and that angle then allows that floor member, if it burns out in the center, it can then fall out of the wall and it will not damage the brick courses above it. The fire resistance of masonry walls really depends on the type of masonry used and the thickness of the wall, generally from 2 to 4 hour fire resistant rating. And it also depends, of course, on the other structural members of the building and the intended fire load in the occupancy. Generally speaking, exterior fire resistive walls are going to be masonry construction. Over time, the mortar joints in a brick or masonry wall are going to begin to deteriorate. It can be exacerbated by rotting wood inside. Here we see a brick wall that has had some repairs done to it, several repairs done to it over the years, as is evidenced by the new mortar joints and the uneven mortar work. And this is a building that has some structural integrity issues to it. So it had issues before a fire occurred in this building. If you see a building that has had a fire in it that has issues like this, it should be looked at with extreme prejudice and figured to be unstable. Now we'll look at the types of wood construction in use. Again, our most common and fundamental structural material we could have very many types of wood, whether it be again the types of wood used or the dimensions used, or whether it's stick built or prefabricated off-site and brought in. The problem with wood as a building material is it actually contributes fuel to the fire. Most fires start in our residences and our commercial buildings with the furnishings and the equipment that we bring into the building, not the building itself. But then once the building itself becomes part of the fire, it now becomes a true structural fire. And wood loses its structural integrity as it's consumed. What we have done now is with the lightweight truss construction, there is nowhere near as much surface area. So those lightweight structural wood members now can catch fire and burn much more rapidly and fail much quicker than a stick-built building will. Heavy timber, again, going back to last week in the Type 4 construction we described, has a structural framework with a framework of beams and columns of wooden timbers that are at least 8 inches by 8 inches in dimension. It's a very basic concept. It's been used for a very long time. Of course, it goes back to the very early wood frame buildings made out of logs. And some of the weaknesses here are the connections between the members and also the mortise and tenon joints, which have largely gone away, and most everything is bolted together nowadays. We have our post and beam construction, or our pole barn construction. Columns and beams are less than used in heavy timber, but greater than light frame construction. Leaves a lot of interior wood surface exposed. One of the advantages is it's a relatively economical and fast type of building to erect. Again, we think of pole barns or storage buildings being a good example of a post and beam construction. Light wood here, we're talking about our Type 5 construction. Use of 2-inch nominal pieces of lumber, which, as we know, are not really 2 inches anymore. A 2x4 is really 1.5 inches by 3.5. They still call it a 2x4. The walls are formed from 2x4 studs, and the floor is supported by joists or trusses. The roofs are pitched or supported by rafters or light trusses, typically a peaked roof or a pitched roof. We have 2 types of wood framing, though. Balloon framing came into vogue in the late 1800s and up into the mid-1900s. Balloon framing, where we would have wood structural members that started at the foundation, the masonry foundation of the building, and ran all the way to the roof line. And then the floors were attached at the appropriate places to those studs. And they would build the entire wall on site, and then flat on the ground, and then with a series of ropes and men pushing it up, they would simply tilt the walls into place and then bolt them or nail them to the additional outside walls to form the exterior walls of the building. It was a very effective way to do it, but there's several drawbacks. We need those very long structural members that are 2 or 3 stories in length, which has become very expensive. After World War II, or about 1945, balloon frame construction virtually ceased to exist, and just about everything built from 1945 on was done with platform framing. We could use much shorter, much cheaper members, and we could build the structure in much less time. The problem with balloon framing was that it would allow rapid fire spread from the basement all the way to the attic, sometimes without even knowing it. And the platform framing has stops built into the walls to prevent that from happening. Here on the left we can see examples of our balloon framing construction, and if you look over here on the side, on the left side, you can see that those structural members run all the way from the footer and the foundation all the way up to the attic eaves. And on the right we have our platform construction, and the fire stops are built in because they literally build the walls up 1 story, lay a platform floor on top of it, and then build the walls up a 2nd story and lay a platform floor upon it, and then the peaked roof. It's built in stages as opposed to building all 3 stories at one time. Exterior wall materials have gone kind of a evolution also. Sheathing is the thin coating that goes over top of the, or not coating, but covering that goes over top of the framing members. Many types of materials, everything from plywood to paper, pressed paper, insulating board to oriented strand board, or OSB. Siding materials, a wide variety of materials going under the sidings of our buildings. And typically now they will use, to insulate the buildings, they will either fill the walls with loose fill materials or paper, blown in cellulose type insulation to provide that dead air space, or they can pack fiberglass type batting into the walls to provide insulation, make our homes much more energy efficient. And last, typically at the outside of the wood frame building, they will put the brick veneer on the outside. And here you can see in the cross-section diagram of the brick veneer being applied to the outside of a wood frame building, there are simply those small sheet metal L brackets that tie the wood frame to the brick. Those brackets are nailed onto the frame of the building and allowed to stick out, and they simply just go into place in the mortar joint and helps to give the brick some rigidity and help hold the brick onto the side of the building. It's rather difficult to determine from outside if the brick wall is truly load-bearing or not. A couple of tricks though, of course looking for that course of brick every 5 to 7 rows that goes in a different direction. That's a dead giveaway that that is a load-bearing wall, not a brick veneer. For summary this week, we need to have some good knowledge of the materials used to build a building and some of the structural components that go into our buildings in order to be able to typically give a good evaluation of whether that building meets specific provisions of the code and how well that building is going to hold up under fire conditions. Combined with the construction types, you can categorize a building by the occupancy and determine the necessary code that goes with that building. Obviously, we would not want a fireworks factory located in the same building as an apartment building. We want to keep those types of buildings separate, and the code requires that they be separated by a certain distance. We would not want to be sleeping over top of something like that, where if it caught fire in the middle of the night, we could have large numbers of people killed or injured. That's a radical example, but you get the idea. In order to be able to reduce risk in our communities, the inspector has to know how the building is built, what types of components go into it, and know how to reduce risk by having good enforcement of the fire codes to keep our community safe.